Shall we start now?
We can start the class now. Good evening, everyone. Today we are going to solve 7 marks in matrices. Shall we start? Yes. So, first sum we have to start as right. So, first today we are going to do some 7 marks in matrices. Shall we start? Yes. The first sum is without expanding the determinant, right? Determinants show that b plus c, c plus a plus b, c plus a plus b, a plus b plus c. So this is the sum we are going to do it now. So what we are provided with, they said we have to prove these things without expanding the determinants, right? Right. Shall we start solving? Yes. So I am start solving by writing solution. So the first thing is I am taking the left hand side. Determinant equals b plus c plus a plus b. Again c plus a plus b and b plus c. Here a plus b plus c and c plus a, right? Right. This is the first thing I am taken, right? Right. So what we are going to do? We are going to replace the rows and columns so that we can able to prove this. Okay, shall we start to solve? Yes. So first thing I am going to do is R1 equals R1 plus R2 plus R3. Okay. Okay. So the determinant will in the determinant we have to replace the first row. We are going to replace the first row by R1 plus R2 R3, right? Right. So what will be the first row? So it will become B plus C plus C plus A plus A plus B. Likewise here C plus A plus A plus B plus B plus C. Here also A plus B plus B plus C plus C plus A. This is what we are going to do in a first step. First step, we taken the left hand side of the given equation, and the first step we are going to do is R1 will be replaced by R1 plus R2 plus R3, right? Right. Okay. I'm rubbing this. So I'm writing the determinant here. So what is R1? So R1 will be R1 plus R2 plus R3. So I'm writing B plus C plus C plus A plus B. Similarly, here also C plus A plus A plus B plus B plus C. And in column 3 also, it will become A plus B plus B plus C plus C plus A, right? Right. At the same time, row 2 and row 3 will remain the same. So it will be C plus A, it will be A plus B, it will be A plus B and B plus C, B plus C and C plus A. Okay? I hope you are clear with this. Shall we move to the next step? Yes. C is delta. So here 2A plus there are 2B's, so 2B plus there are 2C's, 2C. And remaining things will remain the same. Likewise also 2a and here 2b's and here 2c's, and these two remains the same. Here 2a plus 2b plus 2c and other two rows remains the same. Right? Right. So in each term there is 2. So I am taking 2 in common. So it will becomes del equals 2 multiplied by a plus b plus c. Here c plus a, here a plus b. Likewise also 2 multiplied by a plus b plus c. A plus b and b plus c. Here also a plus b plus c. B plus c and c plus c. See, in row 1, in all the places, 2 is common, right? So, I am going to take this 2 as common from all the rows, right? Right. Shall we take that? Yes. So, I hope you are writing along with me so that I can rub and write, right? Right. So, what we did up to this. So, it will become del, which is equals. I am taking 2 from all the elements in row 1. So, it will becomes 2. So what we have here in row 1, a plus b plus c, a plus b plus c, a plus b plus c. Row 2 and 3 will remain same. So c plus a plus b. And again a plus b, b plus c. So it will be plus c, c plus a. Okay. So what we are going to do now is, I am simply going to replace R2 and R3, right? So R2 will be R2 minus R1. Similarly, R3 will be R3 minus R1. Right? Right. So see, now we are going to deal with R2 and R3. In each elements of R2, R2 will be replaced by R2 minus R1. Shall we do that? Yes. Del equals 2 multiplied by R1 remains the same. A plus B plus C, A plus B plus C, and again A plus B plus C. So now we are going to do with R2 minus R1. So here, so what is in this place? It is A plus C minus A plus B plus C. So it will become C. Already we have in R2 C plus A. So we are going to subtract R1. So it is A plus B plus C. Right? So it will become C plus A minus B minus C. So these two terms will get cancelled. So we have minus B. So I am going to replace here with minus B. Right? Right. Likewise, we are going to do for remaining all the terms, right? So A plus B minus A minus B minus C. So these two will get cancelled. What we have here? Minus C. And here we have is B plus C. And in row 1, A minus of row R1, right? So minus A minus B minus C. So B and C will get cancelled. We have minus A. Right? Right. So similarly here, in here, we completed the second row, right? So what is R2? R2 is R2 minus R1. We did it. So what is R3? R3 is also R3 minus R1, right? So what is R3? First element in R3. A plus B minus, we are going to subtract what? R1. So just A minus B minus C. So these will get cancelled. It is minus C. Right? Right. So what is the second term? It is B plus C. It is R1. So these will get cancelled. So it will becomes minus A. Okay. And what is RC? Sorry, R3 here. C plus A. And what we have here? R1 minus A minus A. B minus C. So C and A will cancel. We will have minus B. Right? Clear? Clear. So this is the step we did up to now. So now we are going to touch the R1, right? So now I am going to replace R1 by R1 plus R2 plus R3, right? Right. So it is R3, right? It is R3. So R1 will be replaced by the sum of R1 plus R2 plus R3. So it will be del equals to multiplied by what is R1? It is, so we have R1 as A plus B plus C. So we are going to add R2 and R3. So it will becomes minus B minus C, right? Right. So A plus B minus, sorry, plus C minus B, but minus C means what we have? We will have A alone, right? So it will become A. Okay, here. In second column in first row, we have R1 will be R1 plus R2 plus R3, right? So this the second element will be A plus B plus C. What are the row, second row and third row? So it is minus C and minus A, right? So minus C plus C get cancelled, plus A minus A will get cancelled. What we will have? B, right? So I am writing B in place of this, right? Right. Okay. So what is the last term? This is also A plus B plus C. So we are going to add all of this, right? So it will becomes minus A minus B. So my plus A minus A will cancel, plus B minus B will cancel. What we will have? We will have C alone. Right? Right. So it will be C. And here it will be minus B minus C and minus A. Minus C minus A and minus B. See, in both the terms, see, in this row and this row, we have what in common? We have minus 1 in common, right? So I am taking this out. So it will become 2 multiplied by minus 1 multiplied by minus 1. So what we have in R1? So it is A, B, C remains same. In R2, we take the minus 1 as out. So it will becomes B, C and A. In R3 also we are taken the minus 1 as out. So it will become C, A and B. Clear? Clear. So it is equals 2 multiplied by minus 1 and minus 1, it will becomes plus 1. So it remains 2. And what we have? A, B, C, B, C, A and C, A, B. What we have to prove? Yes, we have to prove this one. Right? Right. So in the question, we are provided with a matrix and we have to make that matrix equal to this one. Right? Right. So we proved this. We can finally write hence proved. So before writing this, we can write the given clearly, right? So what is given in the question? We are provided with a matrix, that is, it is a given matrix. I am copying this from the question. Right, this is the question. We taken this and we changed the rows and we finally got what? This one. So which is equals to ABC, BCA and CAB. Right? We take this one in the left hand side and we interchange the rows and we do addition and subtraction in between the rows and we finally make the value equals this one. So this is what we have to prove and we proved this. We can conclude the sum by writing hence proved. Right? Right. So do you have all understand this sum? Did anybody have doubt in this? If anybody have doubt in this, you can just put it in a comment box so we can solve this down, right? Or else shall we move to the next sum? Shall we move to the next sum? Yes, of course. So I'm going to write the next sum. Okay. So next sum is show that. Here is also a sum which is like a hence proving sum, right? If the question is provided with show that or prove that, we are going to prove the given equation, right? We are not going to find anything. So that one. So the question is show that a matrix is given which will be equal to a minus b multiplied by b minus c multiplied by c minus a multiplied by a plus ab plus bc plus ca. This is what we have to prove, right? Right. Shall we start? Yes. To prove this, I am going to take the left hand side. So solution left hand side is equals 1 a squared a cube, 1 b squared b cube, 1 c squared c cube, right? Right. So I am going to replace the row 2 and row 3, right? So I am going to replace row 2 by r2 minus r1. Similarly, I am going to replace r3 by r3 minus r1, right? Right. So it will becomes. So row 1 we did never nothing change, right? So it will remain the same. So it will becomes 1 r square r cube. So r1 we never touched it, so it remains the same. So what we are doing with r2? R2 will be r2 minus r1. So it will be 1 minus 1. So it will become 0. R2 minus r1. So b squared minus a squared. Again here r2 minus r1. So b cube minus a cube. Similarly, see r3 is also r3 minus r1. Here 1 minus 1. So 0. Here c squared minus in r1 a squared. Similarly c cube minus a cube. Right? Clear? Clear. See these two terms. They are in a format of a squared minus b squared, which is in a form of a plus b and a minus b. Right? See these two terms. They are in a format of a cube minus b cube. What is the formula for that? A minus b multiplied by a squared plus ab plus b squared. Right? Right? Right. So now we are going to expand these four terms using these two formulas, right? Shall we do that? Yes, of course, right? Right. So I am writing which is equals 1 a squared and a cube. So it will be 0 and 0. So here we have b squared minus a squared. So it will become b minus a multiplied by b plus a. Right? Here we have c squared minus a squared. So it will become c minus a multiplied by c plus a. Right? This is in a format of a cube minus b cube. So it will become b minus a multiplied by ab, multiplied by b squared plus ab plus a squared, right? Right. Here also it will become c minus a, c squared plus ac plus a squared, right? Clear? Clear. Shall we move to the next step? Yes. The next step is C. Here in both the terms we have B minus A. Here in both the terms we have C minus A. We are going to take this out, right? Right. So in Whenever we have, so same term is common in 1, 2, 3. All the elements of a row, we can take that. So here see, b minus a is in second term and third term. What about 0? Whenever we are taking this, we can write like this, right? Right. So I am taking b minus a as common from row 2 and c minus a as common from row 3. So I am writing like this, b minus a multiplied by c minus a, and it will becomes 1, 0 and 1 a squared and a cube. So we are taking b minus a out. So it will become 0 divided by b minus a. 0 by anything is 0. And if we take b minus a here, what will remains? A plus b will b plus a will remains. And here b squared plus ab plus a squared. Similarly, we are taking c minus a as common out from all the terms. So it will become 0 divided by c minus a. So it will remain 0. So here it will become c plus a, and here it will become c squared plus ac plus a squared, right? Right. So what we are going to do now? So what I am going to do now is I am going to replace the row 2, right? So I am going to replace R2 by R2 minus R3. Clear? Clear. So it will becomes B minus A multiplied by C minus A. So R1 remains the same, right? R1 remains the same. So R2 will replace it by R2 minus R3. So 0 minus 0 is 0. So R2 minus R3. So B plus A minus C minus A. Right? Here it is plus A, here it is minus A. So they both get cancelled. What will remain? What will remain is B minus C. Right? B minus C. So what we have here? R2 minus R3. So we have here is B squared plus AB plus A squared minus C squared minus ACE minus A squared. Right? Right. So here these A squared will get cancelled. So what we will have? So we will have is B squared minus C squared plus AB minus AC. Right? Right. So R3 will remain the same. Right? Right. I'm going to make it a little bit clear. C squared plus AC, A squared. Right? I'm going to rewrite this term, right? Right. So it will becomes B minus A, C minus A, and 1 A squared A cube, 0, 0 B minus C, B squared minus C squared plus, I'm taking A as common, so it will become B minus C. Here it will be C plus A, C squared plus AC plus A squared, right? Right. So, do you guys have any doubt in this? Do you have any doubt in this? Okay. So, shall we move to the next step? Yes. So, the next step is, here it is B squared minus C squared. We can rewrite it as B plus C multiplied by B minus C. Shall we? Yes. So, see here we have B minus A, right? So, I am taking minus as common. So, it will become A minus B, right? Right. And C minus A. Right. So it will become 1 A square and A cube, 0 B minus C here it will become b plus c multiplied by b minus c plus a multiplied by b minus c. And R3 remains the same. It will be c 0 c plus a and c squared plus ac plus a squared, right? Right. Okay. So now I am going to take one term in common. Which term? As of course we are going to take b minus c as common. So it will become minus a minus b, c minus a. So it remains 1 a squared and a cube. So we are going to take, okay, I can write like this. So minus a minus b and c minus a. R1 remains the same. In R2 we are going to take b minus c as common. So similarly 0 will become 0 divided by b minus c. So something divided 0 by something is again 0. We take b minus c as common, so it will become 1. So here we take b minus c, so it will become b plus c plus we take b minus c as common, so it will remain a. Clear? Clear. And R3 remains the same. Okay? Okay. Clear. Clear. Shall we do the next step? The next step is so simple. We are going to do the determinant here. We are going to expand the determinant, right? Right. So I'm going to expand it column wise. Right? Right. So first I am going to take 1. So it will be like this. So 1 multiplied by this one. 1 into this term will be this term. So c squared plus ac plus a squared. When it goes, we have to add a minus. So it will be c plus a multiplied by b plus c plus a. Clear? Clear. So think of other two terms. So it will be 0 multiplied by anything will remain 0. So and the next term is also 0. So we can directly write zeros there. Right? Right. Shall we solve it? Yes. It's b a minus b, c minus a and b minus c. So it will become c squared plus ac plus a squared. So I'm going to multiply these terms together. So it will become minus. So c and b is minus bc and minus c squared and minus ac likewise minus ab and minus ac and minus a squared, right? Right. So what we will have is minus of a minus b multiplied by c minus a multiplied by b minus c. See here, positive c squared and negative c squared, they will get cancelled. And here, positive ac and negative ac, they will get cancelled. Positive a squared, negative a squared, they will also get cancelled. Right? Right. What we have remaining? We will have minus ab, minus bc and minus a. Right? Right. So, see, initially we have a minus, right? So, I am going to take this minus as common, right? So, it will becomes minus and minus of a minus b and c minus a. Okay, it's not clear. So, we will rub this and write it as numbers. So, it will be minus of and another minus is there. What we have a minus b and c minus a and b minus c. So we take this minus as common from all these three terms. So it will become ab plus bc plus ca. Right? Right. So minus multiplied by minus is plus. So it will become a minus b. And just rewriting this term here and this term here. So it will be b minus c and c minus a Here it is AB plus BC plus C. So what we have to prove? Yes, we have to prove this, right? Right. So I can write now here is 1 A squared A cube, 1 B squared B cube, and 1 C squared C cube. Right? Is equals A minus B, B minus C, and C minus A multiplied by AB plus BC plus CA. Right? I have to prove this. We proved it, right? So we can finally conclude the sum by writing hence prove. I hope you are clear. All are clear with this sum. Do anybody have doubt in this? If yes means put S in the chat. Put your doubt clearly in the chat box. Do anybody have any doubts? Do you guys are clearly clear with this sum? If S means put S in the chat box. No means write your queries in the chat box, right? Okay. Fine. I see nobody sharing your queries. Shall we move to the next sum? Yes. So our next sum is so that so our next sum is show that a matrix, right? We are provided with the matrix. BC plus CA plus AB, AB plus BC plus C plus A, B, C. This is a given matrix which is equals A cube plus B cube plus C cube minus 3ABC. This is what we have to prove. Right? Shall we start? Yes. I'm start writing my solution. I'm going to take the left hand side. So LHS equals. So what is the given question? B plus C plus A and A plus B. Here A plus B and B plus C and C plus A. Here it is A, B, C, right? This is the question. This is the left hand side. So what I am going to do first is I am going to take the R1, right? I am going to replace R1 by R1 plus R3, right? So it will becomes, so here A and here B plus C. We are going to add this. It will becomes A plus B plus C. Similarly, we have C and A in addition here. We are going to add B. So I can write A plus B plus C. Here also we have A plus B. We are going to add C. So it will becomes A plus B plus C. So R2 and R3 remain the same. Right? Right. This is our first step. What is our first step? The first step is R1 replaced by R1 plus R3. Right? Right. So what is the second step? In the second step, I am going to replace R2. Right? So I am going to replace R2 by R2 minus R1. Right? R2 minus R1. Shall we? Yes. So R1 remains the same, A plus B plus C, and again A plus B plus C, and again A plus B plus C. So what is R2? We are going to replace R2 by R2 minus R1. So it will be A plus B minus of R1. So it will becomes minus A minus B and minus C. So plus A minus A will get cancelled, plus B minus B will get cancelled. What we will have? We will have is minus C. So I am going to write minus C here. Similarly, what we have in R2, B plus C. So what we are going to do? We are going to replace R2 with R2 minus R1. What is in my R1? It is A plus B. So we are going to subtract, right? So here plus B, here minus B, here plus C, and here minus C. What we will have? Minus A. So I am replacing this term by minus A. So what we are having here are 2 C plus A. We are going to replace R2 by R2 minus R1. So it will be minus A, minus B and minus C. So plus C minus C get cancelled, plus A minus A will get cancelled. What we have? Minus B. Right? So it will become minus B. So R3 remains the same as A, B and C. Right? Right. So the next thing is, see, in all the terms we have A plus B plus C as common. So I am going to take this out. So it will become A plus B plus C multiplied by a matrix. So it will be 1, 1, 1 minus C minus A and minus B. Here it is A, B, C. Right? Right. So what is the next step? So the next step is we are going to expand the determinant by first row, right? Right. Shall we do that? Yes. So for that I am writing the first thing here. A plus B plus C multiplied by the matrix row 1, row 2 and row 3. Right? Okay. I am clearing the other parts. Okay. So we are going to expand this determinant by first row. So it will becomes A plus B plus C remain the same. So it will be 1 multiplied by minus AC minus of minus B squared. So it will becomes plus B squared minus 1 multiplied by C minus C. So minus C squared. Here while we are doing like this, so it will we have to add a minus before that. So here it is minus AB. So it will becomes plus AB and plus 1 multiplied by minus BC minus of minus A squared, so it will becomes A squared. Right? Right. So we can simply solve this sum. So it will become A plus B plus C. So while solving this, what will I get? Minus AC plus B squared. So I'm going to take this minus inside, so it will becomes plus C squared minus AB and minus BC plus A squared. Right? Right. So I can rewrite this. So it will become A plus B plus C. This equals A squared plus B squared plus C squared minus AB minus BC minus AC. Right? Right. So this seems like any other formula, right? Right. So I'm going to write one thing. What is the formula for A cube plus B cube plus C cube? The formula for A cube plus B cube plus C cube is equals A plus B plus C multiplied by A squared plus B squared plus C squared minus AB minus BC minus AC plus 3ABC. Right? Right. We have this one and this one here in the numerator. Right? Right. So, to find this, we can easily write A cube plus B cube plus C cube minus 3ABC equals, I am just taking this term here, will becomes A plus B plus C multiplied by A squared, B squared plus C squared minus AB minus BC minus AC. Right? Right. So now we are very clear that this will equals this. So I can replace this term by this term. So it is equals A cube plus B cube plus C cube minus 3ABC. Right? Right. So what I have to prove? I have to prove the what we are provided with the equation in the right hand side. We are provided with the same terms, right? We have to prove the given matrix is equals to A cube plus B cube plus C cube minus 3ABC. right? We can clearly write it down and we can conclude this sum. So what is the given matrix? It is B plus C and C plus A and A plus B. Here A plus B, B plus C and C plus A, ABC. So which is equals what we find A cube plus B cube plus C cube minus 3ABC. This is what we have to prove. So we can finally write hence prove. Okay. So do you have any questions regarding this sum? S means put the questions in a chat box. No means put clear in the chat box so that we can move to the next sum, right? So I see no other doubts in the chat box, right? Right. Shall we move to the next sum? Yes, of course. Okay. So I'm writing the next sum first. Okay. So the next sum is little bit different from a previous sum. So in previous sum we are provided with the single matrix and we are provided with the equation. We have to show that they both are equal, right? Right. But in this sum they are provided with different matrices, right? So first matrix they said which is equal 0. Second matrix, the determinant of a matrix is equal 0. In second matrix the determinant of a matrix is not equal 0. What we have to prove? We have to prove that A, B, C equals minus 1, right? Right. Shall we start solving this? Yes. Solution, right? Right. So initially I'm going to just add the given two things, right? Right. So if we add these two things, it will become 0. So I'm going to take this matrix alone, right? Right. Remember, we are provided with two matrices. We have to prove it A, B, C equals minus 1. So what we know? We know this matrix is not equal 0. So we don't know about where it may be. So we are leaving this matrix and we are taking this matrix alone. We know it is equal 0, right? Right. So I am taking this matrix alone. So it will becomes A, B, C, E squared 1 plus E cube and B squared 1 plus B cube and C squared 1 plus C cube, which is equals 0. Right? Right. So I'm going to separate this into two matrices, right? Right. So I'm going to recall this sum once again. See, we are provided with two different matrices and we have to show A, B, C equals minus 1. See, when we take the second matrix, the determinant is not equal 0. So we can't conclude anything with this statement. But we when see the first matrix, we are provided with clearly that determinant of the matrix is equals to 0. So to solve this sum, I am taking this one. Right? Right. Now, according to the rule of determinants, we can separate this matrix into two because in the last matrix, in the last column of the matrix, we can see it is sum of two elements, right? In all the columns, it is a sum of two elements. So I can easily separate this matrix. So other two columns remains the same. Here in first matrix I am going to take the first element alone. What is the sign here? Addition. And first two columns remains the same. And we are going to take these things in a second element in the second column. I mean second matrix. Which will equal 0. Right? Right. So what we did, see, simply what we did means we separate the two matrices, right? Right. By we keep the first two columns as same for both the matrices, and in the last column we take first element to the first matrix and second element to the second matrix. In all the things we have addition, so we put addition here. Clear? Clear. Shall we move to the next step? Did anybody have doubt in this? I once again repeat this. We are provided with two matrices. This matrix, it is not, determinant of this matrix is not equal 0. So we can't conclude anything. So, but the first matrix, their determinant is equal 0. So we take this and when we see the third column, in all the elements, they are provided with two individual elements and they are connected by addition. So we separate it into a two matrices, right? Right. Okay. So I am going to keep the first matrix as it is. So it will becomes ABC and A squared, B squared and C squared. 1. Right? Right. So in this matrix, I am going to take some terms as common. See, in row 1, A is common in all the terms. So plus I am taking A as common. So it will becomes 1, A and A square. Right? Right. In second row, we have B as common in all the elements. So I am taking this out. So it will become 1 B and B squared. Right? See, in third row, we have C as common in all the elements. So I am taking this out. So it will become 1 C and C squared. So which is equal 0. Right? Right. So in the question, we already know that this determinant is also given in a this matrix. This is also given in a question which is not equal 0, right? Right. So I am going to replace this matrix, right, in form of this. So what I have to do? Yes, super. We have to interchange these two columns, right? Right. So first I am interchanging column 1 and column 2, right? Right. So it will becomes, this determinant remains the same. I am changing the columns for this determinant only, right? Right. This matrix is only. So this matrix remains the same. Okay. While interchanging the columns, we have to add a minus, right? Right. So it will becomes A, B, C, 1, 1, 1, A squared, B squared and C squared, which is equal 0. Right? Right. So what I'm again going to do is, and I am going to replace these two columns, right? I'm going to just interchange this. So I'm writing interchanging for which columns? Column 2 and column 3, right? So this matrix remains the same. So it will become A squared 1, B squared 1, C squared 1, C squared 1, right? Right. While interchanging columns, we have to add a subtraction. So it will becomes, already we have our subtractions, it will become like this. So it will becomes A, B, C. So this column will go here and this column will go here. E squared, right? And C squared and 1, 1, 1, right? Which is equal 0. right? Okay. So see, oh, here both the matrix determinant matrices are same. Here also ABC, A squared, B squared, C squared, 1 on 1. ABC, A squared, B squared, C squared, 1 on 1. So I am going to take this matrix as common. So it will become A squared 1, B squared 1, C squared 1 multiplied by 1 plus minus into minus will be plus. So it will become A plus B plus C, and we take this term out. So it will become C equals 0. Right? Right. So go and check the question. We are provided with true matrices, right? Right. So what is given in the question, right? We are provided with A, B, C, two matrices. So this is the first one and this is the second one, right? Right? This is what we are provided with the question. This determinant of this matrix is equal 0. Determinant of this matrix is not equal 0, right? Right. So we take this and we change this to this one, right? We solve this and we find this one, right? So this is not equal, this equals 0. So we use this. What we have remaining? We know this from the question. This matrix here is not equal 0, right? We are given that, right? This matrix is not equal 0. So, okay. Before concluding this, we can write A and B equals 0. So we are going to multiply two elements A and B, right? So to get 0, there must be two possibilities. A must be some element or and B equals 0, or else A equals 0 and B must be some element. Okay? So only we can conclude their final answer will be 0. See, anything multiplied by 0 is 0. So in this case, n multiplied by 0 which is equal 0. Here 0 multiplied by n equals 0. So whenever a product of two numbers is 0, either one of the term is equal 0. Right? Right. Here we are provided with this in the question. Right? This term is not equal 0. This is given in a question. So I can say that this term must be equal 0. Clear? Clear. So I am taking this term. So one we can write clearly, right? From given A squared 1B, B squared 1 and this matrix C squared 1 which is not equal 0, so that we can conclude 1 plus A, B, C is equals 0. Clear? Do you have any doubt in this? Did anybody have doubt in this? Yes. So okay. So now we know that 1 plus A, B, C equals 0. So we can write 1 A, B, C equals 0. I am going to take this 1 this side. So it will becomes A. So it will becomes A, B, C equals minus 1. So go and check the question what we have to find. We have to prove, right? What we have to prove? A, B, C equals minus 1, right? Right. See? So we have to prove. I can write it here. ABC equals minus 1. So we have to prove this. So I can finally write hence proved. That's it, guys. I hope you all are clear with this sum. Did anybody have any doubts? Kindly put that in a chat box. So, okay? Okay. So today we solved four sums. In all the four sums, we are provided with some determinants and we have to prove that determinants is equal to some things or like this one, right? So what we do? what we did, we interchanged their values, right? We interchanged their rows and columns, and we did sometimes we add the rows to a particular row. Likewise, we did, and we finally proved the given things, right? Right. Do you have any doubt? Means kindly put that in a chat box, or else you can leave. Thank you, guys. I hope you all clear of this. Thank you.